Hi, for my research topic is nuclear magnetic resonance and with MRI, which is magnetic resonance imaging. So why I chose this topic? Because my family's elders, like most of them work in hospitals. So because of that, I've spent a lot of time when I was a child in the hospital, and um, those those machines, like I always like playing around those machines. And I learned from my medical elders that they told me the X-ray is slightly less effective than the MRI, and they also says that the X-ray image is more effective at revealing bones, and MRI is more effective at revealing ligaments, muscles, and other soft tissues. This is the the words what they said to me, and because of that, I'm like there's difference between X-ray and MRI, and makes me have a lot of interest in MRI and also the thing called MRI, which is NMR, the nuclear magnetic resonance. And in this presentation, it's mostly different in separate in three parts. Firstly is the history of it. Um, as we developed and implement in the NMR and also MRI scanners that we currently use, it's taken about 7 decades, a long time history. And here is some points that I want to mention. Firstly, in 1882, it is Nikola Tesla which was given the privilege of having his name based on upon the unit of magnetic line density, known as the Tesla. This one is which we learned in 46, and then in 1938, a professor in the Columbia University played a pivotal role in advancing mankind's understanding of the interaction of at atomic nuclei and with electromagnetic fields and apply the radio frequency fields among the other things. And this is dramatically altered mankind's knowledge of the interaction between the nuclear seeds and the electromagnetic fields. And then in 1950s, um, Herman Carr, the American scientist, built the first MRI in the world, and then professor in the State University of New York published the article in the magazine Nature, and since then the MRI has been widespread attempts in the medical world and is now widely used. And the second one is how NMR works. When protons and neutrons combine, they formed a positively charged nucleus. Because the protons has positive charge and the neutrons are neutrally charged, and the neutrons is in a high-speed spin, which is equivalent to the movement of positive charge in a charged particle that results the generation of an electrical current. And when the spin of the system matches the current that flowing to the system, the magnetic field generated. This part we also like learned in school before. And so as a result, some naturally occurring the nuclei with quick spin are magnetic, which consequence of this. When exposed an external magnetic field, nuclei are irradiated by electromagnetic waves or specific frequency, causing the nucleus to absorb energy and transition from a ground state to an excited state, from a stable state to an active state, and this results in the magnification of the nuclear magnetic source. And because the nuclei have the low energy levels and high energy levels, um, and those energy levels have the like have the change in the energy between them, and this makes the RF signal to be utilized to receive this energy, and this energy are shown to T1 relaxation and T2 relaxation, which T1 is mostly a view of an atomical structure, and T2 is mostly to see in the tissue lesions. This one is the atoms, the nuclear and the protons are spinning around. And for my last part, the now usage in NMR is firstly the medical, which I mentioned before. It's the MRI, which used the hydrogen, the hydrogen proton inside of body, because the most of our body is made of water, and this is more clearly to make the images shown to the doctors. And the MRI is mostly like have the clear image of near bone and the soft tissue around the bones, including ligaments and muscles, which also I mentioned in my in my medical elders. They told me that. And also it is used in chemical like metal ceramics and rocket fuel, also like petrochemicals. And for the others is that the new using of the NMR, which is also like might be like a part of MRI, but it is more technical, right? And here's the works cited. Thank you for viewing. That's it.